Hello, everyone. Welcome to Science for Success's webinar on planter technologies. My name is Jenny Carleo. I'm an area specialized agent at NC State, and I also am the project director under Dr. Rachel Van, who's our soybean extension specialist. So Science for Success is a team of soybean extension specialists from across the country. And we are funded by the United Soybean Board. So we use Checkoff dollars to conduct our programming. And since we are a national organization, we'd like to know where you are all from too. So we're going to put up a poll and we would love to know which state you're from. You can type out the whole name of the state and then I will summarize that information and show it to everyone later on in the presentation. So just about Science for Success, as you're filling out that poll, our project goal is really to deliver soybean best management practices to our soybean producers in America. And we do that through a couple of different ways. First of all, we summarize our state-funded research. So a lot of farmers have similar questions from all across the country, and we get together and we make sure that we come up with practical information to solve your questions. And then we also need to conduct research experiments. And what we do is we collaborate on different protocols. Typically, we'll do 1 or 2 a year that are broad reaching and that impact a lot of growers. And of course, an example would be this webinar about how we extend our research to the public. So as extension professionals, that's really our mission here. And that's what we do at Science for Success. It's truly your soybean checkoff dollars at work. So I'm going to close this poll now. And I'm going to go into introducing our speakers. So our topic today is what's new in planter technologies. And our main speaker is Dr. Michael Plumblee. He's from Clemson University, which is the land-grant university in South Carolina. And he's the lead author on the publication that we'll be sharing with you later today. Also, we have for the Q&A session, Dr. Chad Lee. He's at the University of Kentucky. Dr. John Kleinjohn at South Dakota State University, Mike Mulvaney at Mississippi State, and Dr. Emma Matcham at University of Florida. So with that, Michael, I will pass it off on to you.
Okay, thank you for that introduction, Jenny. Again, like Jenny mentioned, today's webinar, I think kind of the overarching goal of this is to highlight some of the technological advances that we've got in row crop planters. Specific to soybean, but obviously they'll be applied to many other different row crops that we're growing in rotation, but really give you all kind of like a bird's eye view of what's out there, where we see some benefit with these technologies and incorporating them into your production system. So, kind of just starting off, obviously, if you kind of keep up with the industry and where we're at, in row crop production and especially with technology and equipment, it's no secret that our planters have advanced drastically over the last 10 to 15 years. For example, the row unit on the left of the screen is what I would consider just a traditional row unit that you would get on a baseline planter. Not to say that it's bad. I think there's a lot of value in having that, but as compared to the row unit on the right, we can pretty much pick apart the planter nowadays and really manipulate and do a very good job at our placement of all of our different products and make sure that within the planter pass, we're doing the best job that we possibly can. So, today's talk is going to kind of highlight some of the major aspects of the planter row unit that we put into a publication like Jenny mentioned, and we'll share that link a little bit later. But really, I think we kind of broke it down into 5 different areas that we wanted to basically highlight or discuss, and that's trash cleaners, the seed delivery system, closing wheels, downforce, and then anything we can put in furrow. So with that being said, as we kind of go through the talk today, be thinking of some good questions that you can ask our panel of other presenters on this talk today, of things that you might be thinking about on your operation, or technology questions that you may have as we move forward. Again, I think that's kind of what the idea of this presentation is in my realm, is to bring ideas to you that you can then further ask some more questions on. So starting with seed delivery, again, just the process of taking the seed, putting it into the planter and getting it into the ground where it needs to be. We've had significant advances in new technologies in this area of the planter over the last several years. With things like seed singulation, we've got improved metering systems where we're running the vacuum on the planter up much higher, pulling more seed to the plate, and then cleaning that plate off to ensure that we've got good singulation. And we're able to also, do a much better job at varying speeds than we've traditionally been able to do. With seed metering, obviously high-speed planting is becoming a new hot topic with different production systems across the U.S. Where we're able to plant at much higher speeds than traditionally that we planted at in order to cover more acreage, more ground in a narrower window of time. But being able to do that and still maintain the accuracy of the meter, I think, is really important. So there are technologies that we've seen come to market recently that have been able to do that. And then obviously variable rate seeding. So that's something that I think there's a lot of interest in, especially with high input prices over the last couple of years. Where can we cut back? Can we save on seed? Can we implement variable rate seeding to do that? But I think moving forward, we still have quite a few questions in terms of, how do we develop a prescription? Does variable rate seeding pay on my farm? What crops does it pay in? And that sort of thing. So kind of the question I have with this or something to kind of lead into the next slide is, can we maximize our accuracy while maximizing our productivity? We don't want to, maybe increase our planter speed, but then have some penalty with that. And I think that's where we start to see some separation in these technologies moving forward. So, looking at the meter, obviously its job is to pull seed and drop it down the seed tube into the ground, into the furrow that the planter row unit's making. Singulation is something that's really important, especially in corn, where we're trying to get, each individual seed placed in the ground at a nice uniform distance apart within the row. In reality, we really don't see a lot of yield impact in soybean with good singulation like we do in corn. I guess the caveat to that would be if we're planting really late with soybean, where we may not have as many days left or time to accumulate sunlight and heat to progress the crop through harvest. If we're planting late, obviously we want to make sure that the plants are more spaced so they can intercept light, do a much better job. And that kind of leads into the double cropping scenario too. I know in South Carolina, we're playing around with this idea of double cropping soybean behind corn. Our planting window is very, very narrow, but we also have a very condensed growing season at that point. So I think we'll probably see a little bit more of a benefit and some singulation at that time. Also, where we have suboptimal seeding rates. So, I think 70 to 80,000 plants or 70 to 80,000 plants emerge per acre is really kind of that threshold in many areas across the U.S. where, maybe we call for a replant. If you tie it into last week's webinar, we kind of addressed some of those things. But, if we have suboptimal rates, I think, again, singulation in soybean is going to be much more critical. So, we have the ability now with some of these meters to plant 99% singulation. That's a great thing. I think it's good. Are we going to see a big return on investment with that sort of singulation in soybean? Probably not. Again, like our speaker last week, Dr. Connolly mentioned, soybeans are very plastic. They can compensate very well, similar to some of the other crops that we grow, like cotton and peanut. So again, we're not seeing a huge benefit in having soybeans singulated, but again, if you're using the planter in another crop such as corn, in rotation with something that it matters, it's definitely not going to hurt you. So again, kind of taking it a step further, we've talked about the meter, but really the delivery system from the meter to the seed furrow, high-speed planting. There's been several different advances from some of the equipment manufacturers, really over probably like the last 5 years in this realm, where they're coming out with these brush type or belt type seed tubes or called speed tubes. You can see a picture of that here on this slide where really we're able to kind of controllably force the seed down to the furrow and place it in the furrow, doing a very good job where we're kind of minimizing some of the roll and bounce of the seed at these high speeds, ensuring that we're doing the best process as we possibly can in terms of, how we're putting that seed into the furrow. What we would consider, high speed planting, I would kind of say in the 7 to 12 mile per hour range. There are people planting up to those speeds in some of these larger fields in the Midwest or out in the Mid-South and the Delta. But in reality, this may not fit with everybody's production system. I know, for example, here in South Carolina, we do a lot of strip tilling with the planter attached to the strip till rig in tandem. Our field size is small, irregular shape. I don't think we could physically plant at some of these speeds, but at the same time, out in the Mid-South where planting windows are narrow, maybe equipment's limited, if we could take a 6-row planter and cover the same number of acres as a 12-row by doubling the speed, there's probably some value in that moving forward. Another technology or kind of, I guess, concept related to the metering and planters in general is this variable rate seeding. And really a basic definition of that is the application of a material, which in this case would be seed, where rate is adjusted based on your location within a field or management zone. And, again, variable rates kind of had a lot of interest over the last couple of years. Seed costs continue to increase, inputs. So I think there's been a lot of emphasis or need for knowledge on this topic. But really, variable rate can be based, or your application can be based map based. You can sit down and make a variable rate prescription on a map, or it can be sensor based in some cases, depending on the input. With the addition of these hydraulic and electric planter drives on planters, it really has just increased our ability to accurately plant variable rate prescriptions. I know, in my program, we've even planted a corn maze in the past, just where we've been able to basically plant a picture and get really good accuracy where we don't even have to go back and cut plants out where the walking alleys are. So we've made big strides in the accuracy there, being able to do some of these things and then be able to get the overall management of the seed down from maybe the whole planter aspect to individual row control. So some of the work that we've done specifically in my program, or at least in the Southeast, we've looked at variable rate soybean in terms of seeding. We kind of a snapshot of the research that we've done over the last 5 or 6 years in several different fields has shown where there was a benefit in the field to doing variable rate. We can see maybe the potential profit of being $6 to $20 per acre, depending on what year it was and the actual field it was in. I think a lot of that potential benefit that we're seeing there is probably from the seed savings standpoint, not so much on the yield increase standpoint. But I think it's also worthy to note that, we have done variable rate trials in fields where the uniform rate that was applied actually outperformed the variable rate prescription that was developed. So I think that, we need to realize too, that maybe not all fields are good candidates for variable rate. Just because we have a variable rate prescription doesn't necessarily mean it's always going to be the most profitable or the highest yielding treatment we could apply. So, some of the limitations that I see with seed delivery technology, kind of, I guess, the white elephant in the room with soybean is just the return on investment. You'll see kind of throughout the presentation, some of the technologies that we do highlight, I think some of them were maybe geared towards or developed more on the corn side of things. So if that planter is being used for corn and soybean, there probably is an economic factor that can be justifiable in adding that to the planter. But as you'll see, there may or may not be some sort of technology that we directly see a yield benefit in soybean, just because they do have the ability to compensate so well. In terms of variable rate, the accurate data interpretation and the development of the profitable variable rate prescriptions, I think, is a big hurdle that we continue to analyze and deal with every year. Some of the questions that we get often are, what are the base layers that we need to use to develop the prescription? Should we be using soil EC? Should we be using Sergo data, historical yield data? I think we have several options there, but maybe one works better for seeding rates and one might work better for, variable rate potash or something like that. So I think there's still quite a bit of work to do there and things to learn in terms of how do we really do the best job at making a prescription as we can. Another good question is, how variable must our fields be to benefit from variable rate? Are we talking a 5 bushel swing in yield to justify it, or maybe 50 bushel swing, in some of these fields out in the Mid-South? I don't know. That's kind of I guess the theory of this is that, everything is going to be very site specific. And then we also compete with other opportunity costs. So, it takes time to develop these prescriptions, to collect the data, to sit down at the end of the year and really go back and mine and see what we did and what worked. So, the time that we take or the money that we're allocating to pay somebody to do that, there may be other opportunity costs that we could capture to make additional farm profit there. So again, those are just some things to think about. But again, is there a yield benefit to excellent singulation in soybean? It may depend on the actual scenario or timing of planting. And then, again, going back to can you feasibly high-speed plant in your area? Like I mentioned earlier, there are limitations to field size, equipment setup, tillage, et cetera. So kind of the next big overarching topic that we have is planter downforce. And this is something that, we've had, on planters for quite some time in some aspect, but I think there's been a lot of focus on newer technologies where we have better control with maintaining or reacting to different soil conditions with downforce. So with planter downforce, really the way that I understand this technology and is the way that it should be implemented is this is basically developed to overcome soil resistance so that we're maintaining a uniform seeding depth. And I think in theory, the idea behind it is that if we have uniform seeding depth, we have uniform emergence with the crop. So in something like corn, where we know that, we might have some yield left on the table where we're not having uniform emergence, this may be something that would have very significant impact on our overall yield. I would say there are other, instances where this technology would definitely probably have some benefit, and that would be areas or scenarios where poor planter ground contact can occur. So this would be like in no-till situations, planting into cover crops, which are becoming very popular in different parts of the country, or excessive residue, rough soil surface or seed bed. I've got some fields sometimes that we get a lot of row unit bounce, and we can kind of dampen that with some of the downforce technology. And then high-speed planting. If we're planting 10 miles an hour across the field, I think naturally that row unit's going to want to lift up out of the ground and probably have some bounce associated with it. So if we have some sort of a downforce technology there to help with that, I think we can see additional benefit there. So the three types of downforce, they all work similarly. We've got manual springs, pneumatic airbags, and hydraulic downforce. But they all kind of react, I guess, to the soil resistance in a little different way. So with a manual spring, we're going to be applying a static downward force only. We're basically setting the load that we want those springs to carry, and then it's maintaining that across the field. Pneumatic airbags, depending on the system, we have the ability to apply static downforce, but we can also lift up on some of these systems where if we're putting excessive force and maybe burying seed too deep, we can pick up on that. And then the same with the hydraulic downforce, where we're applying maybe a static or a dynamic force. And with the dynamic aspect of downforce, this is often when we see a system that's got load pins on it. We're measuring the load that's traveling on the gauge wheels, and then that cylinder is actually reacting to the amount of load that's traveling on that, with hopes that we're maintaining that uniform seed depth. So again, in soybean, some of the limitations I see with planter downforce, again, goes back to yield. The yield benefits, I think, are somewhat variable depending on where you're at. And it may not be worth the cost to add, maybe the Cadillac treatment of the best downforce you can get. For example, if you're planting into a conventionally tilled field where soil resistance is very low and we don't have a lot of things to overcome to get the seed uniformly placed in the ground, we might not see some of that additional benefit. Some of the research that we've done here in the Southeast, we did show that we could impact the rate of emergence on soybean. But again, even with the difference in emergent rates, we never really saw a huge benefit in yield. But again, uniform emergence is less important in soybean than compared to corn. We've established that. And then, again, how variable are the soils across the field? Is there a benefit to upforce? We see that sometimes where we may have a sandier portion of the field where the planter may naturally want to dive and bury seed deeper. I think we're seeing this more in very seed depth responding crops like maybe cotton, where we don't want to plant it very deep, but again, just something to kind of think about. And then what about the residue level that we're planting into? All these different factors I think will help kind of address or assess whether we need to add these technologies to the planter. So moving to in-furrow application, again, this is kind of the third biggest topic of today's presentation. We've got the increased precision and ability to apply a product on the go, in several different areas with relation to the seed. So, we've got the ability now, we can apply liquids, to the seed, in between the seed, below the seed, to the side of the seed. We can apply granular products, on, off very easily, different avenues with that as well. And so I think, depending on the product, we may see some benefit to this, whether it's a biological, that needs to be pretty close to the seed, or an inoculant, or maybe with a nematicide. These are things that we've been thinking about as researchers is, if we need a high rate of a nematicide or something like that, could we offset it from the seed to maybe help with any phyto that we might see on the plants as they emerge, et cetera. And then same thing with fertilizer, applying salts in the furrow, we can have some seedling issues and that sort of thing. So maybe if we're able to shift that away from the seed, we might have some better luck with those products. But again, there's always limitations to some of the different things that we're incorporating. Again, benefit, what is the benefit to having increased accuracy of the product? All these different technologies are going to be great. And I think it's going to give us a lot more opportunities to try different things that we traditionally have not been able to do. But there's a quote that I like to say when it comes to precision ag, and it's really that our precision capabilities have surpassed our decision-making capabilities. And what I mean by that is we have a lot of really good hardware on the market, and we can do a lot of things that we haven't always been able to do. But trying to make that decision of how do we incorporate this, or what's the best way, I think is where it's going to be more site specific on your geography of where you are, your production system, the crops you're planting, the products you're wanting to apply. Again, depending on what we're putting in furrow, how we're doing this, we could enhance or we could reduce, some of the phyto or crop injury that we're seeing depending on the product. But then something else to think about in terms of soybean, our seed rates are so much higher than some of the other crops in our rotation, such as cotton or corn, that, with some of these liquid products where we're using pulse width modulation to apply, maybe a seed squirter or a seed shot, can we keep up with being able to apply product to each individual seed? So again, these are some of the things that I would be thinking about if you're purchasing or thinking about purchasing some of these products specifically for soybean. So our fourth topic, going into row cleaners, I think historically these have kind of been a very basic add-on to the planter. Essentially what we're trying to do is just, move any of the residue or trash that we have obstructing the planter's job to do its job, where we want to really promote good seed to soil contact. But historically, I think with some of the options that we've had, they've been a little bit difficult to set up, especially on rolling topography. It's like you typically would see, especially with a rigidly fixed row cleaner, they're either doing a really good job or they're turning into maybe like a tillage tool, or digging a trench or something like that. So I think there's been a lot of focus here with, some of the floating ability and some of the on-the-go control that we have from the cab, where, we're able to continuously monitor and, set these row cleaners to do the best job that we can. So again, I think the goal of this is to move trash or residue, not really till. And oftentimes with some of the traditional ones that we've had, I think, just the effort and time to go back and keep changing the settings on those, you wouldn't be able to cover any ground by doing that. And so some of these newer technologies have made that much easier as we move forward. So there are several different options to choose from. We've still have rigid row cleaners on the market. You can have floating types. You can have some that, again, like I mentioned, you can control from the cab in terms of, how aggressive they're doing, how they are floating. But then we can add additional features to them as well, whether it's a 2x2 culture, we're putting out some fertilizer, for corn or another crop in rotation. And we can also add no-till cultures for that situation. So I think, overall with a row cleaner, it needs to be more specific to the operation and cropping system to get the most maximum benefit that you can. Again, I think there's a lot of limited yield response from just adding a row cleaner. I think it goes back to what is the technology developed for? We're trying to improve our seed bed that the row unit's planting into. So of course, if we're planting into a heavy residue or a cover crop where the planter's not able to accurately plant the seed into the ground, there probably is more of a benefit from, a row cleaner or having a good row cleaner. But again, I think moving some of this residue out of the way is going to help compensate or alleviate some of these suboptimal stands that we have seen. And so like the last kind of topic that we wanted to address and go through it for today's, presentation would be on the planter closing wheels. So just from my perspective, I think there's been more recent advances in this space than most of the others. But if you look at different, closing wheels that are available, the technology and the options are very broad. I mean, there's so many different combinations that you can do with different styles of wheels, how they actually pinch the row or don't. But I think, again, going back to, what's the goal of a good job with the closing wheel? And I think it goes to, we obviously want to close the seed furrow, maximize or increase our seed to soil contact, remove any air pockets that we might have around that seed. And then most importantly, we don't want to manipulate where the seed was originally placed. So if we're going in and we're putting, downforce on the planter, we've got our trash cleaners and all this, but then everything that we just did is getting reversed by the closing wheel setup that we have, that's something that I think we need to pay attention to moving forward. So again, with the closing wheels, there's really not there. I don't think that there's, one size does not fit all. And I think that's the beauty of this, is it's going to depend, again, soil type. Are we having problems closing the furrow in your current system? If we are, maybe we can just buy a more aggressive or a different style closing wheel to be able to collapse the sidewall of the seed furrow or do a better job. Do we see a yield benefit in soybean from a closing wheel? Some of the research is, I guess, depending on where you're at or the issues that you may or may not be having, historically, there may be. Many of the planter technologies that are being developed, like I mentioned earlier, are probably being developed and pushed really hard for corn, just because it is more responsive to some of the technologies that are being developed. But a simple strip trial that we've done in the past here in the Southeast, where we did not see any difference in closing wheel, where we compared 2 rubber wheels, a rubber plus a spike, and then some cast iron closing wheels as well. And really kind of the note that we took back on that, these were soybeans planted double crop scenario behind small grain. In that particular trial that we did, we were doing a pretty good job of closing the seed furrow across all of the treatments. So if we would have been in a different soil texture, maybe it would have been a lot drier, the ground would have been harder where we were having an issue with that. Or if we would have been too aggressive in pitching the seed up out of the ground, I think that's kind of where we would start to see the benefit from modifying or changing the closing wheels that we've got. So kind of in summary, for what we went through today, again, I think you as the farmer or consultant can now, manipulate pretty much every component of the planter, obviously increasing precision and productivity. So I think, if you have an area of the planter, your specific planting system is giving you issues or you think you can improve on, there's probably a technology out now that could do that. But understanding how the technology performs in a specific scenario or a system, and especially in each crop, I think is really essential. And, lastly, the yield benefit and the quick return on investment on many of these components are somewhat limited in soybean compared to other crops as corn, but not to say that they shouldn't be used. If the planter is going to be used across commodities, for sure, I think the better we can do, the better we're setting ourselves up moving into that growing season, et cetera. But with that being said, that was kind of the initial introduction to what our publication has kind of went into in terms of planter technology. Obviously, it goes into a little bit more detail than what I covered today. But again, we wanted to really give you a good overview of kind of the things that we're looking at and how they respond to soybean. So real quick, before we start the question and answers, we've got a QR code here for the fact sheet. If you're interested in that, it's posted online at the following website. And again, it kind of goes into these 5 big topics a little bit more in depth in terms of, each of the components and where we see some of the benefits as they relate to soybean. So with that being said, I'm going to stop sharing my screen so that y'all can see all of the panelists a little bit better. Again, we've got 5 panelists, including myself, kind of scattered out across the United States. each of us kind of are representing a different, I guess, niche in our specific areas, but really we want to just give everybody an opportunity to ask questions. So there is a Q&A box that, if you do have a specific question, please feel free to chime in and ask us the question, and we'll kind of deviate it out and try to answer the question as best we can. So, with that being said, we're going to kind of start into this. One of the first questions that I see, really come through the chat is saying, for your soybean variable rate programs in South Carolina, what kind of soils have you been cutting back and increasing rates on? And he said, I know it'll change region by region, but just curious. So I guess that was a little bit directed to me. I'm going to answer it, and then I'm going to kind of, ask a few of y'all what y'all have seen in your research as well. But, in South Carolina, with the variable rate work that we've done, we've tried to develop prescriptions based on real data that's come out of the field from each farm. So it's definitely highly site specific. We're trying to gather as much data as we can. But what we've done in our specific systems is, if I wanted to go make a variable rate prescription for a farmer down the road, I would ask him, where's his kind of seed rate that he's, currently uniformly seeding. And then typically what we'll do in the first year is maybe increase that rate by 15 and 30%, and then decrease it by 15 and 30%, and plant 5 or more uniform rate strips across that field, hopefully capturing a lot of the variability across the field and soil texture. We come in that fall, harvest with a yield monitor, and then kind of analyze the data to say, okay, if we come up with different management zones, whether it be EC or some other type of a base layer, what uniform rate responded or performed the best in each of these zones. And so it really kind of depends. What I think we've seen in some of the trials that we have done in our better land, we have been able to back off a little bit on some of the seed rates, and some of the poor sorrier land that we have. We've seen a little bit better of a yield response, maybe where we're increasing that rate. But overall, it is definitely very specific to the field. I think in the scenario, overall, I would say we have a lot of non-irrigated soybean in our state. So rainfall is definitely going to implicate that too. But that's kind of what we've seen. And again, we have had instances where we thought we had a lot of variability in the field, but at the end of the day, when we go and look and do these kind of titration sort of seed rate trials with these uniform rate strips, we don't always see a real big benefit in doing variable rate compared to what the grower was already doing uniformly. So I know Emma's done a lot of work, in the Midwest, and now is in Florida with variable rate. I don't know if you have any additional comments on what y'all seen in the Midwest with variable rate.
Honestly, similar story. In the Midwest, we're seeing that sometimes variable rate seeding can help you reduce your seed costs, but we're usually not seeing increases in yield very much. Soybeans are very plastic and can be productive at a wide range of seeding rates in a wide range of environments. And agreed that in dryland soybean, usually are base layers for management zone delineation that are correlated with water retention or even elevation are going to be better at making management zones than some of the more nutrient availability related parameters. So pretty similar story in the Midwest to South Carolina.
Sure. So I guess kind of piggybacking on that, Mike, I don't know if y'all have looked at any variable rate out in the Mid-South at all yet, or have any interest in doing that. I'm sure there's some people probably doing some variable rate corn, but have you heard anything on these kind of seed rates, or where you're cutting back or increasing or that sort of thing?
I mean, if we're planting at 120, 140,000 seed per acre here, and a bag of soybean seed is considered cheap enough that you'll be accepting higher risk by reducing your seeding rate significantly. So, and we're in early production system. So you really don't want to cut your seeding rates down if you're trying to, hit an early April planting date. So I think from our perspective here in Mississippi, it's a pretty tall order to cut your seeding rates, given the level of risk you might adopt. We just have poorly drained soils. So You know, we don't want to risk flooding out a stand and ending up with a suboptimal stand and risking a replant scenario. So, but specific to your question, I mean, I don't see a lot of adoption of the variable rate seeding technology here in Mississippi.
Okay. I guess kind of another, I guess, seed delivery kind of question. I know there is a lot of interest in high-speed planting, especially in the Midwest. In the Mid-South, you know, Mike, I know you've done some work with that here recently specifically, but, you know, what scenarios or cropping systems are you probably seeing or recommending people look into this high-speed planting? Is it more on the planting window type of thing, or are we trying to keep equipment size small and just be able to cover more acres with less equipment? You know, kind of what are your thoughts on that moving forward?
Yeah, I'm in a pretty good situation in the Delta area of Mississippi, where we've got, you know, long straight runs. Of course, we might have water furrows and things that we got to deal with there too. So given the importance of planting date and the very narrow window, like I said, we got poorly drained soil. So if we get a rain, we could be out of the field for a week or two during that critical planting window. And we know that planting date, along with variety selection, is probably two of the most critical components to maximizing our yield potential. So given that critical planting window, if we can get more acres planted in the same time, in that time frame, we expect to get a yield jump just because we're planting on time. Of course, there's other things you need to consider on the back end of that, is where you're going to put all that. If your bins are all full of corn, you got to make sure you got the capacity to get those beans out of the field into the elevator. So there's a few factors to consider above and beyond just, you know, planting more acres quicker. But you know, conceptually, that's what we're after.
Right. No, that makes good sense. I know with, like, you know, for instance, in the Southeast, I think there is a lot of interest in the high speed planting. It doesn't necessarily fit in with all of our practices, just because we are, again, pulling a strip till in tandem with the planter. We can only go so fast. Our field size is small, but I think there is a lot of value and potential for this, you know, as, you know, equipment prices continue to increase, labor shortages become to be more of a challenge with people. If I can put one guy on a planter and cover twice the amount of acres in a given time, you know, that might be a lot better in terms of a whole farm profitability standpoint, you know, utilizing the technology to the best of our ability. Let's see, I guess another question that's come through is, you know, what are your thoughts on precision planting and branching capacity of the soybean? So, you know, I know, Chad, you've done a lot with soybeans and physiology and some of the agronomic practices. You know, have you looked at anything with singulation and maybe the branching capacity of a soybean? And, you know, if there's any effect on that, do we get more of a bushy plant if we're you know, singulating it very well compared to, you know, erratic drop kind of a planter?
Sure, that's a good question, Michael, and a good question by the person who asked it. Soybeans are tremendously flexible when it comes to low population. And so I think we did some early seeding rate studies, goodness, almost 20 years ago now. And over time, as we've continued to repeat those and repeat them across the US, we find that when we get to these really low populations, so 75, 60,000 and 15-inch rows, that all the beans bush out and will fill in. We've been surprised at just how competitive those beans are, particularly when we're in a higher yield environment. And maybe that's the one surprise, is that when yield levels tended to be at the higher end, we needed fewer beans to get there. And when we got into more stressful conditions, whether it's double crops in our region or just a stressful condition because of a soil type or something like that, then you need to have some higher populations to help overcome some of that. Probably has something to do with those beans, in our case, with the double crops having a shorter window and just needing to get to canopy much quicker. One thing that most of those studies showed was that, you know, we've got to be somewhere close to 95% light interception right around the time that the beans flower, within a week or two after flowering starts, in order to maximize yield. And that's probably the explanation for why those higher populations are needed in the stressful conditions. But, comparatively to corn, which many of the growers on here today are familiar with, beans are much less sensitive to that plant to plant spacing and much less sensitive to population than what corn is.
For sure. So kind of moving along with some of the questions that are coming in, another really good question that just came through would be the grower would be interested or curious to hear what leading coulters people have had success or failures with, especially going into a tall cover crop. There's some concern about maybe hairpinning some of the residue, I guess, with a wavy no-till coulter. But have heard leading coulters can still help with emergence. So I know, cover crops are being grown, all over the country. John, I don't know if y'all been doing any cover crop work in South Dakota. Have you seen any big issues with no-tilling into a cover crop, or where you would think that a no-till coulter could, add any benefit or take anything away from soybean planting?
We are doing a fair amount of cover crop research up here, but unfortunately that's another crew that's leading that up. So I'm not real familiar with the different things they're looking at. I know that my program, we've done some yield trials in soybeans into a knee-high rye cover crop, and we've just used a straight coulter. Seems like we've had great results with that.
Right. What about Chad? Have y'all done it? Or what about in like a no-till situation where the ground's really hard? I mean, are you definitely recommending a no-till coulter every time? Or are you having issues with it where we've got different types of cover crop?
Yeah, it's a great question, Michael. And a lot of our growers are moving to the row cleaners instead of a leading coulter. And the ones that have a coulter, I see more bubble coulter than I do wavy coulter and the heavy residue. I think some of the issues, particularly with some of the wider wavy coulters, is they're not slicing through everything properly. And you went through the adjustments that can be done with the row cleaners, and you showed pictures where they had the silver caps on the one, the other ones were solid. Those are a couple of ways to get around the issue of that cover crop wrapping up on the row cleaners. But the ability to set those row cleaners in the floating pattern and to be able to adjust it, I think our farmers are finding more success with that than they are with that leading edge coulter.
Gotcha. Emma, what's going on in Florida? I know y'all are probably real heavy on cover crop down there. Have you had any experiences down there yet? With any of the planting conditions or issues that you had? I don't know how long residue kind of persists or lingers on in that environment, but
this is actually the first year I've been here for soybean planting in Florida. We do tend to have a little bit less residue at planting. A lot of our systems are pretty heavy with tillage, even if there was a cover crop. But this will be the first year that I get to see Florida soybean planting myself.
okay. And I guess kind of, really what I've seen too is with some of these, it all kind of goes back to, if you can get away with planting with just a row cleaner rather than having that slicing no-till coulter, I think that's just something that you got to evaluate. It's going to probably depend on, how green the cover crop is when you're planting, what the growth habit or how much biomass we've actually got with the cover crop that we're trying to plant into. Kind of going back, I guess, to variable rate seeding, we had another question come through. Variable rate soybean planting will not show a change in yield. Lower populations will compensate for equal yields, but higher populations means a thicker canopy and shading of ground faster. This faster shading of planted ground is utilized as a means of weed and grass control, the best there is in fact. So I guess it was more of a comment with the density. I think as we progress with soybean planting, I think there's more interest in maybe narrowing up row spacing, which is obviously going to probably hopefully help with some of the weed control issues that we have had maybe in traditional wide row soybeans. I know in the South, we've had a lot of wide row soybeans just because we're planting cotton and peanuts on wide rows, but we're starting to see a shift here to the 30-inch and less, 15-inch soybeans, I think are becoming a little bit more popular. In terms of down the row seed rate or thickness of canopy, I don't think that at least some of the seed rates that I've been looking at with variable rate in soybean We haven't really pushed the limit that much on the low end that I think we're having issues with no shading in the crop or weed control issues. I don't know, have y'all pushed the limits that much anywhere on seed rate, just in general, where we're having some issues? I mean, I know it's something to be mindful of and make sure that we're not creating another problem further down the road by doing some of this, but Chad or Mike, I don't know if y'all have any comments to make on that.
If they don't, I do. We have pushed the seeding rate down to about 80,000 seeds per acre in some spots in Ohio, and then had really terrible weather immediately following planting. Ended up with plant stands right around 12,000 an acre. Yields ended up being fine, but we had to go in with another herbicide application because there was no ground cover. And we've also had issues on the other side where we had better than expected weather at emergence. And in some of our higher seeding rate zones had really good emergence and ended up having issues with lodging. So being mindful that you want to minimize risk and making sure that on your very high seeding rates and your very low seeding rates, if you have weather outside of your norm, you're still going to be okay. If you push too far in either direction, you can get yourself into trouble.
Yeah, I agree with that. I think that's something very valuable to kind of point out is, with the range of seeding rates that we utilize for variable rate prescriptions, we obviously want to push it enough that we will see a potential benefit, whether we're trying to cut back to save on seed costs or increase in our poor areas to increase the number of plants that we're putting out there. But, obviously we can't have bad weather. We deal with it every year, dry weather, depending on when we're planting or something like that. So if we do cut back, I guess we want to make sure that hopefully we still get that optimal stand established, that we're not hindering our yield, where we think that even though we might have, really good soil conditions, that, I think that's really important.
Well, and Emma hit on something else here, Michael.
Yeah.
Part of this is a replant question, which nobody's asked, but we'll jump into it for a moment. I mean, the data would suggest, and economics would suggest, that you've got to be below 75 and maybe even 50,000 plants per acre in cases before it would economically justify a replant. It might trigger, and that includes triggering a second herbicide application to help clean up some of those weeds. So, so Emma's first comment about what you said, 12,000 on the low end, Emma. So, I mean, that's tremendously low. You're harvesting little bushes out there at that time. Right? Very, very hard on the cutting bar on the machine. But the point is that these beans can handle extremely low populations, well below what any farmer thinks is acceptable. And as long as that field's not in the main road where everybody sees it, or it's by the shop, probably safe to go ahead and leave it.
Yeah.
And speaking of cutting bar stress, we actually measured fuel usage and engine load and didn't have any noticeable issues there.
It's interesting point. I don't know if anybody else has got like a lot of, or any other real specific questions that's on the presentation today. We had one more come in kind of with regards to the termination of a rye. Are we rolling or crimping or chemical control and that sort of thing? And I'm assuming this is kind of more related to, are we seeing better planting conditions where we're rolling the rye or crimping the rye, or, planting green or desiccating it? I can speak for my state. I think a lot of it's probably, just depends on the grower. I think we have a little bit of everything. I think we have people that are planting into standing crop. We've got some that are rolling it down, maybe even rolling it with the planter in the same pass. We've got some that are going out and burning it down, and then, it's really not having a big impact on their planting operation. I'd say the people that are planting into it green or even crimping it ahead of the planter, they're definitely going to have the more aggressive trash cleaners, no-till cultures, et cetera, to make sure that, we're getting good soil to seed contact. Again, it kind of goes back to our operation here. We are doing a lot of, strip till into these things. A lot of our strip till rigs have got, maybe a no-till coulter on that, or it's got some kind of fluted coulter behind it where it's still able to move some trash. So I think it really just kind of depends. I'd say that, if you're wanting to minimize the impact you would have on the planter doing a good job, for example, with rye, I would think that, leaving it standing and then killing it would probably be a little bit easier to plant into rather than rolling it down in a mat and leaving it green. But I don't know, is anybody on the panel had any experiences with that, or, have anything else to add in terms of what they've seen with planting into some of these different types of cover crops and things that, everybody's kind of leaning more towards?
I mean, I've seen, people trying to terminate late and their rye cover crop late and then end up with a stand effect, just we think because of allelopathy. So what we try to do when I was at Florida is we would want to terminate that cover crop and hope for we didn't have irrigation, but hope for a leaching rainfall event to wash some of those chemicals out of the seed zone prior to planting. So that's one thing that we witnessed on some of our farms down in the southeast.
Yeah.
I would say in
We've got
South
some
Dakota. Oh, sorry, Chad, go ahead.
Well, we've got some growers that are doing a roller crimping with some GMO beans and chemical control. It's working pretty well for them to do it that way. Some disease pressures, elevated slugs are a bigger issue in that type system. Got some organic farms that are doing it as well, but their issue is by the time they plant, they're getting good suppression of weeds in between the rows. It's within the row where they've cleared out the cover crop residue. They're getting a flush of weeds in there to the point it's defeating the original purpose of why they crimped it over. So we have a similar stance to what Mike just said, where we'd love to see the crop terminated at least 2 weeks before, chemically terminated at least 2 weeks before we plant, to prevent the cover crop from becoming a weed on the cash crop.
Right. We've had 2 more questions come through, so I want to kind of address those, before we kind of have to wrap up today. But
you got a South Dakota perspective on cover crop.
Yep.
Oh, I didn't have much to add there. I was just going to say most of ours is killed with chemical control, and the big no-tillers in the central part of the state, they want to plant into standing residue. They don't want to roll it down flat or have to deal with anything like that.
Right. So kind of these last 2 questions, one's more related to the variable rate seeding, and one's, I guess, more online with maybe some of the planting date effect that we have on soybean. But the first question, in exploring soybean variable rate seeding, this individual is exploring it on the results from soil microbiome, soil sampling, specifically disease and fertility. Have any of us or any institutions done any work working with the microbiome data? So I'm assuming they're trying to, alter seed rate based on what's going on in the microbiome as a data layer compared to maybe soil EC or some other data layer. I would say, at least from my perspective, no, we have not looked at that yet. I mean, that might be something that we need to start looking at. At least in my state, traditionally, we don't have a tremendous amount of soybean disease, I guess, from a seedling perspective. Fertility really with us, we get a lot of leaching in our sandy soils and that sort of thing. I think we're making a lot of poultry litter and traditional fertilizer applications already, but that might be something moving forward. We've got very low, I guess, organic matter soils as well. But has anybody even heard of any of this work being done for data layers?
No, in Ohio, we've done some with fertility. Organic matter and pH were more successful than some of our cation nutrients for generating maps. One thing is with the soil microbiome data, making sure that it's sampled at a scale that makes sense for variable rate seeding is important. Some of those tests are very expensive. And if your planter is able to change rates every 10 feet, but your sampling is every 10 acres, it's not going to be very high resolution data, and you're not going to be able to get a very map with very many different zones in it.
Right.
I know trace genomics can pick up on things like white mold. And I don't know, Emma, if you ever did anything like that when you were in Wisconsin, but we do have producers that are varying their rate. They're cutting their populations way back in areas of the field that have high white mold pressure. So haven't done any work on that specifically at the college, but I know that producers are looking at it.
That makes sense too. You know, we had a lot of seedling disease in our area with peanut, you know, a little bit different crop, but you know, we've seen some differences where we alter seed rate and kind of the progression of the disease down the row, where we, you know, have really thick stands or a lot of seeds in the row. We kind of see the progression of the disease being able to spread more than where we're spacing it out. So that definitely makes sense if we have historical data showing some of the diseased areas of the field where we could alter seed rate to maybe help slow or stop the spread of some of these diseases. I think we have time for
We've done work on having 2 hoppers with different seed treatments.
Right.
For variable rate.
And that's something that we didn't really get into, but I think is maybe worth mentioning is, you know, we talked about a lot of technologies, but we do have the capabilities now to do some multi-variety planting. So if we do have, you know, host plant resistance in certain varieties that we don't in others, you know, that might be a good opportunity for that. You know, we don't really have white mold and soybean here, so I can't speak to what varieties are available, but, you know, we've done stuff looking at, you know, hybrid selection, whether it's irrigated or a dryland corner, and swapping hybrids based on kind of how they respond in corn, obviously. But, you know, I think there's some bleed over with that on soybean. But I want to finish up with one more quick question before we kind of wrap things up. The last question I've been asked, if the benefit of the precision of a row unit planter is worth planting or worth waiting for that planter to finish planting corn to plant soybeans, or if it is better to plant soybeans earlier with a less precise method, such as a drill or air seeder. Generally, is the benefit of earlier planting more beneficial than precise planting? Do you have thoughts? I would say, you know, kind of based on our conversations in the past, you know, some of the other webinars that we've had, and some of the fact sheets that we've had come out, I'd say, I think that the planting date effect is probably more of low-hanging fruit than the precision seeding with a soybean. You know, I'm assuming all of y'all with your head nods are kind of, you know, on the same page with that probably a little bit better to jump in there and get it planted quicker rather than wait just for the precision, at least in terms of a soybean. So with that being said, I'm going to share my screen with everybody one more time, and I'm going to start. So hopefully everybody can see back at the presentation view. And let's see. I know Jenny's going to hop back on and say a few last remarks for today's webinar.
Okay, great. Well, if you are a CCA, we have this QR code that you can scan with your app so that you can get credits. We have 0.5 credits of crop management. And if you don't have the app, you can email me with your CCA number and your full name, and I'll get those applied for you. I'll come back to that QR code in a second. But we also want to invite you to our next webinar, which is the same time next week. It'll be on Friday, and it is on nitrogen fixation and sulfur fertility in soybeans. Dr. Ignacio Ciampidi will be presenting on that topic. We have a lot of work that we've done, a lot of our team members have worked on, and he's from Kansas State, so he'll be giving that presentation next week, and I'll put the link in the chat box for you to register for that as well. So we did have a great representation from across the country for our poll. I'm not able to show the graph of it right now, but we even had someone from Bangladesh and from Czechia too. So thank you all for making the time to be here today. I'll look forward to seeing you next week. And of course, you can also follow us on Twitter. We're at Soybean Science 1. Thank you, everyone.
Thank you all.